Well, good afternoon, everybody. My name is Mark Orr, and I've got the lovely job of being the Executive Director of Interspill. Interspill is part of a triennial series of spill and pollution response conferences, which take place in Europe this year and in Australia next year, and then back to the good old United States of America in 2024. And then it will come back to Europe again. For Interspill this time, we led really by the exhibitors. We felt that whilst the technical conference is fantastic and it's got lots of good merits, it doesn't always focus in any detail and get under the skin of some of the problems which our industry and our environment is trying to address. And so with the help of the trade associations, and in this case, particularly NOSCA Clean Oceans, we decided that we would do a section, or we'd have a sector theme day, which will be on the 23rd of June in Amsterdam, on the clean seas. And we selected 3 topics. And what we're doing in these series of Interspill informed webinars is exploring these documents, these topics in some detail. And so really it's my pleasure to sort of share these with you. So at Interspill, there'll be 2 sector themed days, one on shipping and salvage, and one on clean seas. And so what we've been doing is we've been doing this series of 3 webinars with the support of the trade associations and academia. We've done one on coastal darkening, and that was fascinating. It's a very current issue, and it's to do with the darkenings of the coasts around our shores, primarily caused through pollution running off from the land, causing slime and bacterial buildup on the sea floor, which prevents the absorption of light, which has a direct effect upon the marine ecosystems on which our life and livelihood from the seas depend. And you can see the recording for that access through interspill.org. This one is about marine debris and plastic pollution, something which is very, very pertinent and very high on all our personal agendas, I suspect. And anyone who goes to sea will just go sailing or uses the water will just see the effect that marine debris and plastic pollution is having on it. And the final one will be to do with emerging pollutants. And these are perhaps things which in the past, it has seemed acceptable to dump our waste products in the sea. There's also been marine incidents, wrecks, things like that, which as they decay are releasing pollutants into the sea. That one is on the 8th of June. And we've also been doing a series of shipping and salvage ones. And you can find more about that in the on interspill.org. In the UK, as there is in Norway and in a number of the other trade associations, we formed our own plastic pollution working group. And this was really to support local authorities who have responsible for shorelines, but when issues occur, didn't know what to do. And so we formed this multidisciplinary group of member companies, regulators, academia. Now we've got waste management companies, we've got marine scientists involved, where we're all trying to discuss in our own ways how we can solve local solutions. Marine debris is a big problem, and I think many of you would have seen TV programs, nature programs, led by in our country we have Sir David Attenborough, and in many countries you'll have marine scientists, ecologists, environmentalists for whom the damage that we're causing to our marine environment bring those images, and sometimes very sad images of trapped animals, but generally marine debris is causing huge problems. And in this webinar we're going to look at marine debris and we're going to look at plastic pollution. So marine debris is defined as any persistent solid material that is manufactured or processed and directly or indirectly, intentionally or unintentionally, is disposed of or abandoned into the marine environment. And today there is really no place on Earth which is immune to this problem. A majority of the litter and debris that covers our beaches comes from storm drains and sewers, as well as from shorelines and recreational activities such as picnicking, beach going, or coastal sailing. Abandoned or discarded fishing gear is also a major problem because this trash can entangle, injure, maim, and drown wildlife and also damage property. So where does this all come from? A lot of it is land-based debris. So human activities which end up with discharges of this debris into rivers, into estuaries, and then out into the deeper ocean. And sometimes whenever you walk along a riverbank, you see debris. And then you go there a week later and there's been a really high tide, or the river level has increased, and suddenly you go back a week later and much of that debris has been washed out to sea. And so what we do on land has a significant effect to what ends up in the sea. Obviously, then there is ocean-based marine debris. This could be litter from ships, it could be fishing gear, it could be gear which has been lost from vessels or from oil platforms, all sorts of vessels, or all sorts of debris which is created at sea. And then, of course, there is disaster debris, debris from abandoned vessels, debris from buildings. And after every tsunami, you see huge pictures of debris which is being taken from the land and dragged out to sea. And that is all contributing to the marine debris problem. But what is the scale of the problem? Regrettably, it is a large and growing problem. And it's estimated at 23 million metric tons of plastic waste per year. So this excludes ocean and disaster debris. This is what the world generates, which ends up going into our seas. That's 23 million metric tons. However, National Geographic forecast between 22 growing to 58 million tons per year. And this includes commitments from governments and industry, and we'll comment on that later. But what is the source of the problem? If we do not change, and if pledges are not honoured, then 99 million tons of uncontrolled plastic waste would end up in the environment by 2030. Now, to visualise this, that's a dump truck tipping a load of plastic into the ocean every minute, every day for a year. It's a football stadium filled with plastic every day. And the issue is the rising tonnage of plastic in the sea. The growth of plastic production is outpacing the world's ability to keep up with collecting it. And collect it we do. And I'm sure from whatever country you are from, you will see people going litter picking rubbish off beaches and doing what they can to keep their local environment reasonably clean and free of litter, particularly those who live in coastal communities or beside rivers. There's always people out picking up litter because it all helps. Surprisingly, it is actually having an effect. So this mobilization of citizens does help to prevent it increasing, but people can't do it all alone. So there are possible solutions. So production of plastic is forecast to more than double by 2050, increasing to have 756 million tons is anticipated to be produced in 2050, from 308 million tons of plastic produced in 2018. That is a monumental increase and something that we will never be able to keep up with. So I'm going to hand over now to Josh Duran, who is from the UK and Ireland Plastic Pollution Working Group, and he's going to take you through what can be done and who can do it.
Yeah, Mark, are you all right to actually just keep the slides on yours, and I'll just give you a cue if that
very
works?
Happy to. Yeah, you just give me a virtual kick. Yeah.
Yeah, no, that'd be brilliant. No, thank you for that. And
Okay.
yeah, hi everyone. Yes, thanks, Mark. So yes, I'm Josh John from Oracle Environmental. We've been part of this the plastic working group now sort of since it starts, and then my background's in marine biology. Personally, I'm a surfer, I'm a scuba diver, and this, yeah, so on a personal level, was something that's quite close to my heart. So yeah, that's the one. So obviously it does come from the consumers, and it comes from us. You know, our choice of plastics, it's about us going out and doing beach cleans, but also it's coming up from that top-down approach, engagement with manufacturers and sort of government-led. So it's the old saying, sort of reduce, reuse, recycle. And there's a reason reduce is at that first point, because what we want to ultimately do is stop the plastic at the source. So there are hundreds of plastic-free products that you can get already out there. I'm sure many of you have these. So it's trying to go towards these where we can. And when plastic has to be used, as at the end of the day, for a lot of people who have diabetes or any other sort of medical conditions, plastic is the only alternative. So what we need to do at that point is start encouraging plastics that can then be recycled, and go down that route. So a global goal is to enable 100% of plastic produced to be recovered by 2030. Where we're at now at 2022, hopefully we're on a pretty good path for that. And the fact that we're talking about this today, and it's a big factor in Interspill, is all positive work. Next one, please, Mark. So as mentioned before, it's that bottom-up approach, but it also needs the power from government-led, looking at trying to stop the use of single-use plastics, and then reduce the packaging. So I'm sure that getting your Amazon deliveries, you get more cardboard in those now, which is good. So this is the point about engaging with consumers. So the consumers understand why there's change and it needs to be implemented. So as I was saying, with shopping, I'm sure you go do your local shop, you come back and put that in the fridge, and you're coming out with loads of soft plastics, from your vegetables to everything. And ultimately what we need to do is look at those different alternatives, buying brown bags and getting the loose veg, when you don't always need everything to be wrapped in plastic. And most recently, there's been in the UK, led by Greenpeace, is the big plastic count. So actually doing a bin audit at home for 1 week and working out how much plastic do you actually produce and come back from that. So as I said, it's engaging with consumers and ultimately will understand and accept the changes. Next, please, Mark. So possible government-led solutions. We've already seen this in the UK and also worldwide, with the the plastic charge on bags that came in 2015, with a reduction from 7.4 billion single-use carrier bags supplied to major supermarkets in 2014, reduced down to 564 million bags over 2019 and 2020. So this is already a huge change and is really positive. That's come from a government-led solution. So this has also been rolled out in Portugal with similar results, and a reduction resulting in 75% reduction in Portugal, and Ireland 94% reduction, and the Netherlands 91%. Secondly, the ban on microbeads in rinse-off cosmetics and personal care products in 2018, in the UK, which was led largely by NGOs such as Greenpeace, Fauna and Flora International, Marine Conservation Society. That's putting pressure on the government, and we've seen that it's promoted change towards sea salt, reused coffee granules, and even olive stone grounds. So this is instantly something that actionable we've been able to come out of this, and it's one of those success stories from government intervention. Next, please, Mark. So this is the most important change government can make in the face of adverse issues to plastic cause. To delay the UK government, since 2019, signals have not are not serious about the problem. So 35 countries worldwide have adopted some of the EPR, which is the Extended Producer Responsibility for packaging for 2024. So again, it's looking at understanding householders, packaging waste, and packaging in street bins managed by local authorities. So again, it's all sort of government-led initiatives that are hopefully going towards away from plastic. Next, Mark. So another success story, which has been rolled out in many nations, sort of largely in Europe, as you can see, Germany, Belgium, Croatia, is the plastic bottle return scheme. So in my own experience, when I actually lived out in Sweden, this was fantastic and actually enticed you to collect your plastic, because what it would do, you take that all in with your shopping, put it in these containers, and then you get your receipt, and then you use that money off for your weekly shop. So again, this is another brilliant success story where we're making sure that plastic bottles are recycled and they're not just thrown in landfill, which when may themselves turn into pollution into the seas. Next, please, Mark. Yeah, brilliant. So again, another thing that we need to look at is so encouraging the recycling and reusing. So like I said, that hierarchy of reduce. When we can't reduce and we have to use plastic, then we should be looking at reusing as much as we can. And then once we've sort of maximized our reuse out of that, that's when it hopefully should go towards recycling. And that's the main part, really. So I'm sure many of you have got sort of fleeces and jumpers made out of old plastic bottles that had another life previously. And as you can see from this long list, they can be made into several different, 100 different products, which is fantastic. And again, it's another really beneficial part which people go towards. They look at, oh, okay, you know, my sunglasses are made out of ocean plastic, and they feel like they're doing something positive from that. So so again, that's another really good part from there. So sorry, Mark, this is 18, is it?
Not sure what slide number this is.
That's all right.
I can go with that one if you like. Yeah.
Yeah, no, if you don't mind taking that one.
Yeah, no problems. So basically, in the UK, only 9% of plastic waste is currently recycled. Now, that is a really, really low level. And if we compare with other countries in Europe, they achieve much higher plastic waste recycling levels. And basically, the model to follow is that you need small projects which can grow to medium-sized projects, which gain some momentum because they end up getting public support. But the initial start of them may be small amounts of funding from government, either government nationally or government locally, through all sorts of innovation schemes or business startup schemes, to give these organizations a chance to grow and to flourish. However, what more recently a lot of local governments have been doing is saying, look, the problem is whilst these small projects are good and they need encouraging, why can't we convert waste material into energy? And so you've seen a flourishing of energy from waste plants, and this basically shows how an energy from waste plant works. Effectively, it burns the waste. However, it generates a lot of electricity at the same time, so it is being, in a sense, the waste is being reused. Personally, you get a 90% reduction of trash to volume. You end up with power generation, but most importantly, you control the emissions going out of the chimney at the end of the process. It is controversial because many people don't want this in their backyard, but it's certainly got to be better than exporting it. It's got to be far better than putting in a landfill. But really, we should be doing what we can to recycle and reuse, convert the recycled material into reusable projects. And energy from waste plants work well when the price for waste is low. At the moment, the price for waste plastic is reasonably high. Is this really the best long-term solution? But it seems to be the solution that many countries have adopted as a means of controlling their waste. It's certainly far better than landfill. So what else the local government can do is it can encourage local recycling initiatives. With prices at an all-time high, you want to encourage people to recycle. You want to encourage a behavioural change which enables waste to be recycled and then remanufactured into something. So what we need to do is local authorities and local government need to push waste management countries into ethical local collection, separation and revenue generation for local people. And then you perhaps get buy-in from people. Equally, universities need outlets for research. They need partners. They need they need interdisciplinary teams, which is ideal with universities, to come together and to create ideas which they can then work with NGOs and work with volunteers to implement. And NGOs in this process are all essential because they have the ability to be neutral and therefore they can hold governments to account. Likewise, NGOs can lead citizen science. Citizen science is playing a really important role. Many of us probably, as I am, towards the later years of our life, have got inquiring minds and we've got energy and we have the knowledge to do things, to try to attempt to do in our small way to enable change. And NGOs, working with NGOs is a great way for us to help in change. And information which we give of our time, we create information which the NGOs can use to put pressure on government. NGOs can also mobilize large numbers of supporters, and they can be very effective at national, but particularly at local level. And local authorities need to help to deliver coordination, logistics to support these volunteer efforts. An example in England, and this is one of my most favorite pictures, was created by Surfers Against Sewage. And what it was trying to do was to create interest in the 1,000-mile beach clean, a really simple message which people could unify around. And they managed to achieve their 1,000-mile beach clean last year by getting local people, supported by local authorities, to get out and clean their beach. And other NGOs are trying to encourage plastic-free communities, and they're doing webinars, they're meeting people in village halls and saying, right, this is how you do it. And I know these things are really small, but what they're doing is they're changing our culture towards waste, and that has to be encouraged. So how do we beat the problem? Now, we've given you some ideas what governments can do. We've given you some ideas on solutions. What I want to do now is to share the learning which 3 companies have had. And there's, so we've got Sveinung Nymark from Novumer, who's going to talk about the projects which his company has been involved with. Neha Mehta from Desmi, who's going to talk about a really interesting project they've done out in Delhi. And Bard Haug from Spilltech, who's going to talk about what they've done. And then we'll then talk a little bit about the circular economy and the importance of investing time and effort in making the circular economy work. So Eric Lang will then conclude this section of this presentation. So I'm going to stop sharing and hand over into the capable hands of Sveinung.
Thank you very much. I will just share my screen here. Is it all right?
Not yet, hasn't come up yet.
Everything looks fine here by me.
No, I don't think it's up. Just click on it again.
Okay. No?
Not yet.
I've got this frame around my screen too, indicating sharing, but
we can only see the main screen at the moment.
okay.
That's it. It's coming. It needed a hit with a hammer.
Yep.
That's it. That's the one. That's great.
Okay, good. So this presentation is about our experience of shoreline cleanup in the Arctic environment. Let's see, I need to change this there. So I will talk about the Cleaning in the Arctic, which is a project funded by Norwegian Retailers Environment Fund. And as the previous presenter, there is a charge buying plastic bags in the grocery stores and supermarkets in Norway. And this fee goes into this fund, which then finance cleanup programs all over the coast. And the ambition is to clean 40% of inaccessible coastline of Norway. And these areas are selected due to the amount of waste combined with high risk. And in addition, it's very remote and sometimes very poor or no mobile signals at all. And of course, in case of emergency, we can expect prolonged response time. We have been assigned 4 areas, and I will focus on the Finnmark county in the Arctic. So just to show you where we are, top of Europe, top of Norway, this is Finnmark. The arrow points at the North Cape, and this is our designated area for cleaning. The distance here in a straight line from east to west in this area is 180 kilometers. But our mission is to clean within this area 1,100 kilometers of exposed shoreline. In advance, the environmental analysts have estimated around 50 kilos of litter per kilometer. But after 6 weeks of work in last season, we covered 125 kilometers and we collected 25 tons. And that really is 4 times the estimate. And the latest news is that last Tuesday, we started up this new season. So they've been cleaning for 1 week. And in 1 week's time, they have the workers, the team, have covered 1 kilometer in 1 week, and they have collected 30 cubic meters of waste. There are several challenges related to this project, especially in the north. It's a very short season. We have around 4 months of operation before the weather changes, and even in summertime, the weather changes rapidly. So in an hour, it can go from calm to storm, and we cannot always rely on the weather forecasts. The surface is both steep and rocky, and often very slippery. On the 2 pictures on the left, on top and the middle, you see examples of the steep and rocky surfaces. In addition, we find a lot of non-plastic waste, for example, pressurized containers. We find ammunition, explosives, and chemicals. The lower picture on the left, you see a 50-liter gas tank. And our problem is it full or is it empty? Is it pressurized or is it not? Does it contain flammable or toxic gases? Another challenge is the logistics. We have to travel long distances to the nearest harbor for offloading and resupplying. So what we do is that we leave shore for work and we stay at sea for 1 week at a time before returning to harbor for resupplying. And of course, a cleanup team, they live together 24 hours a day, and they have limited personal space, and they have very hard physical work during the days. So our teams are selected. We have 2 teams, 7 persons each team. They work back to back 14 days at a time. The teams include a supervisor from Novo Mare and the crew on the ship, and 4 beach cleaners on each team, and they are all recruited locally. Luckily, the teams are very dedicated and they are performing excellent despite the difficult conditions. And just to give them amounts of the time, we expect to spend between 16,000 and 17,000 man-hours in this project. Of course, the safety aspect is crucial to this project. Novo Mare performed an extensive risk assessment prior to startup, and this led to several working procedures. For example, a procedure for safe work performance, also for first aid. The risk communication, we need to make the teams understand what we expect from them, what risks are at hand, and how to handle them. So we have a kickoff, the start of each season. We spend 1 day in communicating and conveying our expectations to them. We need them to understand and them to handle the risk. We also provide first aid training and CPR practice. We provide safety equipment, like, of course, personal protective equipment, but also communication kits. We have portable defibrillators, stretchers, etc. And we need to test them. So we train them in advance, and we test their capacity by performing exercises throughout the first week of work. The equipment available to us is Basen, the ship you see on the top left. This is a rebuilt 30-meter work ferry. It's ice-classed to operate in this area. And the spacious deck and capacity combined with accommodation for all makes it very suitable for us. In addition, on the lower picture, we have 2 rigid buoyancy boats, each equipped with outboard engines, and they are virtually unsinkable. Our experience is that we find much more waste than estimated. And of course, then we work or progress slower than estimated. And also because there are a lot of steep and rocky surfaces to cover. We find that the waste origin is mainly from fishery and the fish farming industry. And luckily, we have had hardly any incidents or accidents to man. We have had a few material damages. So up till now, in these 4 areas we are working, this is our experience. And thank you for your attention.
Thank you very much. I think that's fascinating. While we're changing over to Neha, if you can stop sharing, Neha, you should be able to share. Did you find any animals that were entrapped in any of the waste or killed by any of the waste that you found?
No, we have not found any trapped animals. We have found animals like whales and eagles, but not caused by any debris.
Okay, lovely. Hey, it worked.
Can you see the screen, Mark?
I can. If you can just go to full screen to slideshow, that would be great. Hey, that's it. Lovely.
Yes.
Thank you.
Right. So I would like to say thank you to you, to Interspill and Clean Seas for allowing us to share one of our case studies. It has been a great learning for us in many different ways. So I will just walk you through that. To introduce myself, I'm Neha Mehta and I'm Senior Vice President for the EnviroCare business in DESME. Giving you the basic definition or basic business ideas of DESME. DESME is old Danish company established in 1834, and we are one of the biggest in marine and offshore sector, and the second largest in supplying oil spill response equipment. Under our EnviroClean segment, the orange one you can see, and the segment has three main business legs. The oldest and the most known is the oil spill response, where we supply the equipment and systems for the industry. The second is for the seaweed challenges utilized for keeping the beaches clean and the coastal areas clean, protecting the marine life as well. And the third is the marine debris. You cannot see the picture due to the videos on the side. And this is the business I will be talking about. So marine debris and combating the plastic pollutions in the rivers and the drains. We started the business with combating the plastic pollution in the oceans, where more of our focus changed and we wanted to go more upstream, closer to the source of pollution. Our primary agenda is to control the waste in the cities, closer to the cities, so we don't have the waste going downstreams from the drains to the smaller rivers, to the larger rivers, and to the big rivers and our oceans. And then there is less to collect on the coastlines as well. The next aim is to recover the waste as much as possible and as close as possible to the source, given also the thought that when you collect the waste closer to the source of pollution in the cities or where it has been dumped, the quality of the waste is much higher. So its suitability and capability to be recycled is much better. And that is why it's very important for us to collect it there. It is also a general understanding and a proven fact, I would say, that then the waste you collect in the cities or the closer to the source is also a much cost-effective way of cleaning it compared to collecting the waste on the coastlines or collecting in the oceans. Becomes very equipment heavy, manpower heavy, systems heavy, and the nature is very unpredictable. All my slides covered with the camera screens, or can you see the full slides?
No, we can see the full slides.
All right. Then keeping the source of pollution and the growing plastic pollution challenge in mind, DESME in 2018, we launched the first project of EnviroCare in Delhi, and the capital of India. The project was done in a drain called Barapula, and I'll show you why we took that drain. So most of the studies declare that the land-based sources are the 80% contributors of the ocean plastic. Only 20% is generated by the fisheries. And then these land-based sources, the primary reason of this land-based pollution going into the oceans is rivers. Wind, of course, makes some contribution, but the rivers are the main contributors. And now many of the studies actually define that it's 100 most polluting rivers or 20 most polluting rivers, how we should consider and how we should map the pollution. So one of the McKinsey studies showed that if you take 20 most polluting rivers in the world and try to close those 45% of the load, if that could be controlled, we can control 50% of the ocean load. And keeping that in mind, we started to go into the top 10 most polluting rivers. We went into the river Ganges in India. That is the second most polluting river in the world. And we tried to see actually where is the Ganges getting the pollution from. So the river you see here is the Yamuna River, which is the biggest tributary to the river Ganges. So we started also going more and more upstream. We started mapping where the Yamuna is getting the pollution from. And we actually mapped a drain here in Delhi that was contributing quite a lot of plastic pollution and many other kinds of pollutions to this river. And we actually launched a project here in 2018 together with the Ministry of Science in India. You can see the barriers have been put here and a skimmer has been put here to control the load. Initially, very mechanical and basic system has been used. We call it enhancer to control the waste. It was labor intensive as well. And however, very cost effective to collect the waste. And it worked quite well. This is the picture of after the waste, the installation has been done, and after 1 hour, how it looked. And after the project has been launched, various newspapers and various studies has actually been found that 30%, this drain alone was contributing 30% of Delhi's waste to this large river. And what we did, we tapped it, we closed it completely, 100%. So no waste from this drain was going out. You can see here, I don't know if the picture is very clear, this below this waste that is there is actually a drain, the Barapula drain where we did the project. So this drain is completely covered with the plastic pollution, and it seems like just a land space where you could walk. And this was the condition of the drain earlier. So keeping the high influx of the waste in mind and the challenges of monsoon, all kinds of different debris coming in from trees to cows to refrigerators to dogs. We designed automatic cleanup systems, skimmer systems. And here you can see the picture of our RISE series. It has been a good learning for us to actually make the tailored solutions as each and every, I would say, the place which needs cleanup has different interfaces to the land. So these systems has been designed to take and actually been compatible with most of the drain areas, most of the small rivers and large river areas. The impact of this project has been huge. So until now, this year, we will be closing down this project because the response has been so good, the results has been so good. And we have actually noted the drastic drop in the waste influx since early 2019 and until now. There has been around 8,000 tons of waste that has been collected. And initially, the first year, there has been huge plastic waste. Then the nearby societies and the local slums started to engage. They have been given jobs and opportunities to actually work with the DESME systems where they could come and learn. So we created some waste management awareness classes. They have been given medical facilities where they could stop going into the drains as they are very poisonous, I would say. It's clean sewage water going in. and they have been taught to use the safety gears, gloves, mask, and different things also when tackling and working with the waste. The project has been blessed by many authorities and has been showcased nationally and internationally. The scale up of the project has been wonderful. That was the project where we started, which was co-funded by DESME and the government of India. And now we are scaling up, not only in India, but many other places as well. The solutions until now that has been included in the portfolio are very limited, but very strategic, that can tackle most of the sites. And here you can see this is the Niger River in Africa. The solutions can be tapped here. This is the dam. The solutions can be installed here. So in different locations, how the calculations can be done and how we can manage the marine traffic as well. The solutions are compatible for most of the places. We are also working on supporting the municipal authorities, city authorities, to actually tap the locations and close these leakage points. So we are not transferring the waste from one city to the other city, and actually cleaning the city. So we have a benefit on the socio-economic aspect as well. I strongly believe that our societies deserves to be clean. I myself come from India. I have seen the waste. This is something we grow up with, but I have also seen different. And I would say that I would like to have the different, and I would like to see our waterways as healthy, clean, and beautiful. So we look at the waterways and say these are rivers and not just drains. Any way we could help, any way we could do a project together. DESME is very open to all kinds of discussions. We support and supply equipment to NGOs as well, different authorities as well, private sector, public sector as well. My contact details are here. Please feel free to contact. Thank you.
Thank you very much indeed. I mean, what it does show is that within the industry that we work in, we're very fortunate in that we have a lot of people who are innovators and who are prepared to invest time listening to the problem that people have and creating innovative solutions which are tailored to solving their problems. But the first step comes with those organizations reaching out to us. So Bard, do you want to share yours?
Mark,
Sure.
there is a question which is saying if we have caught any.
Sorry, yeah, go for it. Go for it.
Sorry, but I just answered this question. The question is that if we have caught any fishes or any harmed any marine life with these projects, no. I would say because the first mechanical equipment that have been used, they are also very much on the surface, and no fishes are just on top of the water surface. Then the automated solutions that are there, they are basically conveyor belts, series of conveyor belts. And the fishes, again, the depth of these systems are put in a way that we normally don't catch anything. So I have not, we have not caught any living organisms. However, we have caught more than 100 dead animals that have been dead before and not because of our systems. Thank you.
Bard.
Yes, thank you. So, yes, I was asked to present a case study from our toolbox of products, having 3 different products to present. But before that, I will make just a brief presentation on what Spilltech is and our fields of business. And here you see what we have. Firstly, we have oil spill recovery. That's our heritage and our knowledge base. And then we also sell some flood protection equipment and chemical absorbent products in the Norwegian market, and also some supportives like helmets and motors. But today we are going to talk about litter in water, and this is a rather young company. So we started out designing what we today call a toolbox with a lot of different products, because we know that no single tool can help all problems. And today we will take out 3 of these products from the toolbox and present for you. and the first one being the port bin Tide. And this was the situation when the company was established in 2016 by the owner of the company, Trond. And this was the situation in the closest port, looking like this. Not pleasant situation, even though it's not as bad as what we see from India, I would say. But we were asked to make an idea about how to solve this problem, and we made a suction system based on a oil spill skimmer that was sucking in nearby debris into a bucket, and from that bucket you could easily remove the debris. So that was the first product that we presented in 2017. And this was actually not, this was given by a question from the port itself. Could you please, based on your knowledge, make a product that is doing what we want it to do? And that's the dialogue we normally have with the market, trying to answer the questions that comes up. And so in 2017, having a 1-year development, we presented this, and this is actually the picture of the first port bin Tide, who is there and still is there working 24/7 the whole summer season, where they take it out in the winter because of the ice situation. But that's how it looks like today. And now we have sold, I think it's close to 40 units of this. And this is feedback from one of our very happy customers that said that it is collecting efficiently, and it's collecting more than 4 kilos of debris every day. Not very big amounts, but in the Norwegian or Scandinavian situation, Northern Europe perhaps, this is a very good result, keeping the ports clean. And what we see, a lot of our customers, they use this for more than one purpose. It's not only collecting debris, but it's kind of an educational situation where they ask, for example, this is from the western parts of Norway, the city of Bergen and the port of Bergen, where they ask pupils to come and analyze, make kind of science or what they find collected from the port bins, and they learn how to behave, because this way they can understand that debris is not going to happen. It's not going to be in a bin on land and not end in the sea. So this is a very interesting educational situation. Today, it has evolved from 2017-16, and today the port bin Tide series is 3 different sizes, from the smallest standard one up to the largest one, who is 1,000 liter, and is the one you can reduce the frequency of inspecting and emptying it. Yes, and the second product I will present is something very close to what we saw from DESME, a river collector who is based on high-speed booms from the oil industry. And this example is from the city of Oslo, where they have chosen to make the river green, and they have placed this, who's named the trash trawl, in the almost end of the river, and it's collecting debris all the time. And it's the same principle as you saw in the prior presentation, where the debris goes from one side of the river into the other without hindering the boat traffic in the river. And we also experience that it's almost 100% collection. And this is how it looks like today. And it's a volume there of 1,000 liter. And I believe they empty it every 3 times a week now in the river, Akerselva River in Oslo. And they are collecting quite a lot, even though this is compared to what we have seen before, a rather clean situation. And also they tell us that they do science on what they collect. And what they say that what they learn from analyzing what they collect is a very good upstream decision information. When they see what they collect, they can analyze it and see where are the weak parts of the collection system on land, because what ends up in the river is what's not collected well. And they also have seen that from the industry upstream. They can see whether the industry upstream is having a good tidy situation or not. And they actually have taken industry using the river for not what they should use it for, and in hindsight go back and say, hello, you have to sharpen yourself on where you leave your waste. So it's kind of a police management system, because they can observe what is not supposed to be there in their analyzing system. So this is now also a product on the shelf from us, and we can deliver it to several rivers around. and that's from the fact sheet that we use in the market. And the third and last product I will present is what we call the shore cleaner and the shore cleaner family. And this was based on a few years ago, we had an accident where plastic nurdles were dropped into the sea from a Norwegian boat, ending up on the Norwegian coast, the Danish coast, and the Swedish coast. And a lot of small nurdles, and you've probably seen it. And now I think you see it on the backdrop of Mark's picture there, all those nurdles. And to collect these nurdles, that is quite laborious and almost an impossible job. So we decided to see whether we could find some equipment to do that. And we developed the shore cleaner, who is a kind of a vacuum cleaner. We have used this many years before, and then we sucked up oily bark because we made that initially when we saw that when you have oil pollution on sandy shores, on the shores, you add bark and then you have to remove the bark afterwards. And we have redesigned it so it's now efficient on smaller debris pieces like nurdles, smaller plastic pieces, etc. And what we've seen, people using this device, they tell us that compared to other conventional methods, they increase the efficiency of cleaning up by a factor of 20. Several people have told us that when they've tested out the product on beaches. And then we also saw that when you are on sandy beaches, you will collect, especially when it's dry situations, dry conditions, you will collect quite a bit of sand into the system. So when you take what you've collected and take it into our sifted, the pulp been sifted, and there you see it, is quite a simple arrangement where you split up what you collected into 3 parts. The smallest part, that is of course the sand that will go through the whole system and down and be left on the shore, back on the beach. And these larger parts, that's what you normally want to leave back, not all of it of course, but all your shells and all that kind of stuff. And in between you have these very much higher concentrated bead fraction that will be more efficient to take with you home and take away from the nature. So that's the shore cleaner family. Today, the shore cleaner family, that is the pulp and sifted, as we saw. And we have the shore cleaner XL, who is a slightly larger version. And then we have an intermediate or a smaller version, that is the pulp and shore cleaner medium. And perhaps in the future, there will be a smaller one too, that will be carried by one man. But this is our way of thinking, making a lot of tools for removing debris and litter from the shores. We're from Norway, and we sell most of our products in the northern parts of Europe. And this is where we have distributed and sold our products at the time being. Hopefully, we will be selling more in the future. And if some of you listening to this now should find an interest in becoming a distributor for our toolbox and product family, feel free to contact me later, because we're really interested in increasing our markets, at least in Europe. So then I will end with my very short presentation of all the products in a speedy film. First, we have a couple of pulp and tights, the standard products, sucking in there, and then the XL version, the much larger volume, 1,000 liter volume, working 24/7, operated with a crane because it's big. And then you have the trash troll that I mentioned. And then you have the robot. I haven't mentioned that this time, but that will be for another time. Automated autonomous device collecting litter. And then you have the shore cleaner itself, the large one there, the XL. And then you have the seabed, who is collecting debris from the seabed down to 20 meters of depth. We know that most of the debris ends up on the bottom, and to find a solution for collecting from the bottom is also very crucial for us. So that is under development, and hopefully we will be in the water this summer. 2 ways of collecting. larger items and smaller items. So that's it. That was the 10 minutes from SpillTech. Thank you.
Lovely, thank you, Bard. I mean, what is interesting is that I think all of us who are close to the environment can see that there is a need for a group of innovative solutions which can be tailored to suit individual environments. And what is important is that when we recover it, that we can do something with it. And Eric's going to talk a little bit about how we create that circular economy, which is essential. So Eric, it's over to you.
Thank you. I'll share my screen. Can you see it?
It's coming. Just needs to go on to full screen, unless that may not be or may not be.
It's already
on. Okay, great, good. Go for it.
Yes, thank you. Thank you for this opportunity to scratch the surface, so to speak, of how we at Norska Clean Oceans work with waste recovery and circular economy. My name, as you said, is Eric Langeland, and I'm the General Manager of Norska. Now, Norska Clean Oceans is an innovation cluster developed from the interest organization, some of you might know as Norwegian Oil Spill Control Association, where the members have cooperated about sales and marketing of oil spill control technology since 1993. But as an innovation cluster, our focus is broadened to incorporate unwanted effects from marine biological threats and marine pollution like ocean plastic. We are a national cluster, but we have the main office in Bergen, which is the Norwegian ocean capital. In the cluster, we work purposefully and systematically towards finding solutions to marine pollution challenges. And we always aim for a holistic system solution approach when doing so. An innovation cluster is sort of an umbrella organization, tried, tested, partly funded, and strongly supported by Norwegian authorities through more than 20 years. The general idea is that if you manage to gather resources mentioned in the model, concentrating on a common area of interest, you have a good basis for starting and running dedicated innovation and development. These resources should ideally represent established companies and startups. You have authorities or public agencies, you have investors, and last but not least, you have research and education parties. In Norska, it's a principle that everything we do on the technological side should be supported by research out of respect for the ecosystem. In Norska today, we have around 65 members and cooperating parties, and you may know a few of the logos. The quote to the right is in fact my own, and the main point is cooperation is key. Now, through the shift from interest organization to innovation cluster, we have also changed our strategy, and we now concentrate our effort within 3 focus areas where we see a possible transfer of knowledge and technology. It's oil spill prevention and environmental control, which is about covering future spill control needs for oil production and new energy carriers like batteries, hydrogen, ammonium, and so on. It's holistic industrial solutions for marine pollution, which is about tackling other pollution challenges like silt, ocean plastic, and so on. And it's marine biological threats, which is about detecting and removing organisms that bloom where they should not in large quantities and pose a threat to business and ecosystems, for instance, algae, jellyfish, seaweed, and so on. For each area, we have task forces where the members share knowledge and ideas, and if an idea catches on, we let it mature in a pre-project or pre-study until it is ripe enough to turn into an innovation project, which again then is founded and owned by consortiums of members. We have a common value chain that both serves as a specification of where we are active, namely in the water, in the sea, and a framework for development work where whether we aim for new knowledge or technology or both. And this is detection, the ability to detect a find, that is knowledge and technology like satellites, radars, lidars, drones, sensors, and so on. And then there is classification, which is the ability to classify a find. That is knowledge and technology like laboratory, sensors, and analysis. Classification is important because there are so many different kinds of energy carriers, organisms, and pollutions that all demand their own variation of tools. Which brings us to the next part of the value chain, the ability to clean up a find. That is the tools we need to use or develop together the find, like vessels, booms, pumps, curtains, skimmers, filters, and so on. And finally, the ability to dispose of a find in a sensible way. That is the knowledge and technology related to what we can do with the find. Can it be a resource into new value chains? And this is often challenging because there will always be various degrees of degradation, pollution, etc. in a find taken from water. When addressing a challenge, we aim to include science, engineering, and marketing perspectives in the process. The engineers among our members claim they can solve anything, surprisingly, but we need input from researchers, as I said, to know whether the idea can be realized in a sustainable way and to ensure that the end result makes more good than harm to the environment. In the process, we also need to consider if the solution is replicable, scalable, and has a commercial potential. And since a lot of our work is targeting immature markets, we also need to address regulatory or infrastructure imperfections that needs to be altered to ensure that the solution is both sustainable and can have a commercial potential. This is part of the holistic picture and is also actually welcomed by authorities because they acknowledge that something coming out from the cluster is or tend to be more neutral and perhaps factually based than what's coming from individual companies. We don't necessarily have the same commercial agenda. When it comes to waste recovery and circular economy, our latest example is a recent study we did on how to design a circular value chain for ocean plastic. And this incorporates both ownerless ocean plastic and ocean plastic from known sources. The study is partly financed by Vestland County Council. As a coastal county, Vestland is eager to support sustainable development, and the political management is also preoccupied with the environment. The county was Norway's first to develop a plastic strategy, both targeting things like the use of the singular plastic and also how to clean and enable infrastructure to be able to clean in a sensible way. Now, the goals of this study were to find out what the principal value chain should look like and what actual value chains we can build today, given our level of knowledge, technology, and infrastructure. Also, what we need to do to develop other more sophisticated versions of the value chain in the future, which might demand more development, and what knowledge and technology gaps we need to close in order to do so. This approach was a mix of going through recent studies and reports, focus interviews, workshops, and analysis. And we believe that this structured methodology is transferable to other areas of waste recovery, early phase work as well. In some way, the principal value chain is a more detailed version of the Norska value chain I showed you a couple of slides back. We have the upstream activities. Those are the activities regarding the mapping, finding out where the possible sources of ocean plastic can be. Next is the detection, the actual work you do when you plan and do the actual cleanup. And it's also application of tracing technology you need in order to trace the plastic as a feedstock through the value chain. And finally, it's the first sorting, the coarse sorting, where you divide the find into different fractions. Next is the midstream activities. It's the logistics, of course, because, for instance, in Norway, as this is not an established functioning value chain today, stakeholders are scattered all over the place. So there's a lot of logistics involved. And once you manage to transport things from a site to a plant, then there's the next step, which is washing and fine sorting. And then you can start the granulation or chemical recycling, where you turn the plastic into a feedstock. And then comes the material analysis, where you need to do in order to find out what you can actually use the plastic for. Which brings us over to the downstream activities. You have product design with ocean plastic, which both needs to incorporate solutions, products that are competitive, both in quality and to a certain degree in price, but also designed in a way that makes them easier to recycle again when the customers are done with them. Then you have the actual production and the distribution and sales and the return scheme. And here comes the circular element. You need to apply a return scheme that enables you to get the used products back into the value chain when the customers or the consumers are done with them. So this is the principal value chain. When we looked at what is possible today, on short term, we concluded that there are two possibilities mainly. One is products from ownerless ocean plastic, which is more suited to making products that you can use to build knowledge and shaping attitudes and behavior among customers, consumers, because you can sell the products with a story that also informs them about the problem and how they can take an active part in stopping more ocean plastic to reach the water. And then there is a slightly more possibility that has a slightly more commercial possibility. We think it's products from post-industrial ocean plastic in closed loops, where you know what the plastic is and where it comes from, and you can collect it and transfer it into new products. Both of these value chains should be possible to design today, but they have some challenges that we have identified, also in a country like Norway, where we tend to brag that we have a very sophisticated logistic or system for this infrastructure. The main challenges when it comes to ownerless plastic is the amount of plastic. Can we get quantity and quality that is suitable for making large enough series to make the producers able to invest in forms and production technology? Then there is the efficient detection and tracing technology that can be further refined. It's also professionalized and finance cleanup, as for instance, Novo Mare told us. This is starting to improve, but there are still some gaps to be closed. Then there is the professionalized and efficient first sorting. It's the logistic part that I mentioned. Efficient compaction before you transport. Actually, it should be possible to get ocean plastic down from a ratio from 6 to 1 if you shred it on site before you ship it to a plant. But the reason why I marked this in green is that this is the next area we are going into and doing research within. Then there is the lack of experience when it comes to design and production, and of course the lack of competence when it comes to the lack of competence and the lack of channels and competence to communicate. When it comes to closed loops, post-industrial ocean plastic, the main challenges are lack of local waste stations. It's lack of knowledge and attitude and behavior among the users of the plastic, the companies. It's lack of mapping and tracing systems. It's lack of tested technology. It's lack of knowledge sharing about raw material and what it can be used for, the quality you get when you granulate it. It's lack of cooperation on product development, which is also kind of all over the place for the time being. And also there we see that there is not necessarily a great wish from the traditional plastic producers to lean into this. And then there is the lack of standardized product design, return arrangements, and of course, competitive price. So yeah, with that, I conclude my presentation. This is just scratching the surface, as I said to begin with. There is a 60 pages big report stemming from this company, also pointing towards what we need to do in order to make other value chains that might work in the future by transferring and developing new knowledge and technology. But this it's in Norwegian, so you would need to learn to read Norwegian first.
Google Translate, yes.
That you can. Okay.
Thank you. That's Eric. That's great. Thank you very much indeed. I mean, there is a lot about ocean plastic, and certainly where I have seen products being sold, they tend to be an emotive purchase, which isn't necessarily driven by the price of the product. Whether it is a recycled sort of with a phone case, which comes from ocean plastics, or as there was a number of products which were being talked about in the Global Plastic Forum a few months ago, where they were actually, Dell was trying to use ocean plastic as part of its in the build of the cases which went around their laptops. And I think these are laudable aims, but you do need a big brother partner like a Dell or a large company who can see that as part of their corporate social responsibility. Well, I hope those case studies were interesting. I want to press on because this is a problem which can be beaten. I think we can, within our community, the spill response community, manufacturers, academics, consultancies, manufacturers, we have a huge depth of knowledge and we have a thirst for innovations. And most of our trade associations like NOSCA, like UK Spill, SRG8, SICAPOL, who are all involved in Interspill, we all have links with universities and innovation bodies. And these problems are not new for the spill community. And one of the problems that we're facing now is, particularly at the moment, is what do you do when containers fall off vessels? And the industry's first major experience of this was the MV Rainer, which in October 2011 just sailed onto a reef off the coast of Africa with a total, and the vessel ended up breaking up. It was a total loss. It was at the time carrying just a mere 1,368 containers. Fortunately, efficient response and a lot of innovation by the people who are working in quite dangerous environments, they managed to recover 77% of the containers. But there was oil release and there was debris from lost kilometers, which extended hundreds of kilometers from the point of loss, which included quite a significant nurdle loss. And at the moment, the last year, there was the very sad loss of I think it was a 4-month-old container feeder vessel called the MV Express Pearl, which ended up having a fire on board in the containers. You can see it in the early days of the fire. It was leaking nitric acid. The nitric acid reacted with something else. It ended up causing a container fire. It couldn't put the fire out. They tried to get a point of refuge back in Hamad in Qatar and Hazira in India, who refused to allow the vessel to come in. And it ended up anchored 7 nautical miles off Colombo on the 19th of May. It ended up the fire caught hold on the 20th. And despite attempts to extinguish it, the vessel burnt out by the 20th, 30th of May. And the salvors decided there was no way it was going to be recovered. When they did so, unfortunately, the vessel broke its back when towing started, and it ended up as a total loss. But the consequences of that the consequence of 3 containers carrying plastic pellets each container had 26 tons of nurdles was effectively, or in some areas, meter high little mini mountains of nurdles. And it is the loss of the vessel was immense. It was highly polluting, very disruptive, and has impacted over 60 kilometers of coastline. And the effects of this may continue for years. Now, what is useful, the good thing about this, is some of the lessons learned from Rainer could be applied in this instance, and to a greater degree, the nurdles have all been removed. What we don't know is how much is still left beneath the sand. And the work is going on now to work out how to recover the rest of the nurdles from the sand itself, from the beaches and from the sand itself. A considerable human effort has gone into dealing with this. And unfortunately, the product couldn't be recovered at sea, had to wait to shore to be recovered. And as I say, its effects will continue for years. But what it has done is it stimulated the spill community to really look at how we can deal now with incidents like this. And certainly in our plastic pollution working group, and there are other working groups going on dealing with these issues, we are putting together best practice protocols for dealing with incidents like this. Because with the number of containers which are floating around the ocean at any one time, of which over 3,000 were lost over the side of vessels last year, these incidents will not be unique. There will be more than one per year. And unfortunately, we all need to be prepared. Not that I'm trying to be gloomy about it, but we need to have solutions in place so that we can respond quickly to incidents wherever they occur in the world. Because the more quickly they are recovered, the less harm there is to wildlife and to the marine environment, which is impacted by these incidents. So, you know, that was what the average used to be. That was what it was roughly last year. Unfortunately, I always thought containers sunk until one day I was sailing down to Madeira, and there was something, it was quite windy, and we were sailing downwind in a 55-foot yacht. And somebody saw something, they were on lookout, they saw something, we couldn't work out it was until we went past it, and we'd missed a container by a couple of meters. Had that 55-foot yacht with 12 people on it hit that container, I suspect would have ended up down the bottom of the ocean in Davy Jones's locker. But the issue we have is containers are going to continue to be lost because weather is changing, vessels are getting bigger, container handling systems perhaps and securing systems aren't as good as they should be. But that is a topic of another webinar we'll do before Interspill in the shipping and salvage series. So anyway, these are the sort of things which happen. This is one Opus which lost a lot of containers, over 700 containers last year. So I want to bring this to the conclusion, to this webinar to a conclusion. What should we be doing? Governments, wherever they are, have to take clear action. They must introduce, if they haven't already, extended producer responsibility, so there is a sort of ownership of ownership of the life cycle of plastic that is being produced. Governments must use their purchasing power, which is immense, to force change. They must encourage, where they don't exist, deposit return schemes. And you must incentivize recycling to create new markets for plastic, as they did with paper. Local governments must take clear action. Again, they must use their purchasing power to force change locally. Support local deposit return schemes. Support local NGOs to help clean the environment and provide some of the administrative support which they need to be more effective in their local communities. This way we can change the culture of waste and we can really make recycling easy to do. NGOs, of course, must continue to hold governments to account and use the citizens to hold their local MPs, their local governments to account, and also mobilize citizens to clean their environment, help them take ownership of how their local environment, their local rivers, their local watercourses look. Encourage citizen science. It's a great way of mobilizing and in fact enthusing people and informing people of the harm that waste can do, because this helps to change the culture of waste. And of course, innovate and be encouraged to bring forward ideas. Everybody's got many good ideas within them. So what must we do? Well, we're all informed. We're all attending a webinar which is about plastic. We must be a catalyst for change, set an example, use our businesses, our enthusiasm, our knowledge to support NGOs, and in the end, to help our community. Right, I banged on enough, and I'm really grateful for our presenters. Questions, right. We've covered the one on DESME, that's great. Harry Norton still asked, much of today's presentation has been on larger types of debris, but how large an issue are microplastics, and are there any ongoing projects addressing this type of pollution that you can talk about? Well, Sri Lanka and Express Pearl is providing a huge amount of data, which is all being analysed by various working groups across the world, and start watching out for that. And if anybody knows where there are some sources of available information currently, do have a look. But there we will, within UK and Ireland Spill Association Plastic Pollution Working Group, we will be doing a series of webinars on with the work we're doing and the sources of information that we're finding. But the sources are there, and in general, they're all available. Josh, thanks, Eric. What are your thoughts on, instead of recycling plastic to produce more plastic products, which have the potential to being pollution in the future, we should be completely removing plastic from the environment and encouraging non-plastic projects? I think that's really true. Eva Morales, thank you, Eric, great presentation. Eva is a specialist in creating circular economies, and particular in trying to develop products which people can then use, because we do need to see plastic being recovered, recycled into new products in the same way we're used to doing with paper. That was pretty much it from questions. I'm going to open the floor so anybody can ask any questions while I summarize. I want to say our thanks to the following. Mimi Throne-Holst, who is the research director of SIMTEF. She can't be on it this afternoon, but will watch the recording. She is the mentor for our series and has helped me bring these disparate groups of individuals with knowledge together. Josh from Oracle Environmental, the UK and Ireland Spill Association Plastic Working Group, who's helped me with presenting. Sveining Neimark from Novumer and Noska Clean Oceans. Bard Hauge of Spilltech. Eric Langland from Noska. Neha Mehta from DESME, who's also a UK and Ireland Spill Association member. Before I go, are there any questions that anyone has to offer, or questions or any statements anyone wants to make? The floor is yours if there is. Yeah, Eric.
Yeah, just a quick comment on the microplastic issue, because Noska Clean Oceans is actually a member of the board of the North Atlantic Microplastic Center. And the reason for that is that we need to know how, because today's macroplastic is tomorrow's microplastic, right? So we need to know the long-term effects of it in order to help us create a burning platform for the macroplastic issue. So, and they also really endorse the inclusion of businesses in that environment, because we might at some point also be able to handle and apply technology that can handle the microplastic issue. In addition to microplastic, the researchers are also very preoccupied with the chemical bleed from microplastic. So that's another issue as well.
Great, thank you, Eric. Anyone else got any points? Any points at all? If there aren't, then what I'll do is I want to again thank our presenters. I would also like to say Oh, Sally, thank you very much for putting that up. These are in chat. There are some very, very useful. Paul Harold has put up a really good point of contact there. Paul works for National Public Health England, I think. Sally has put up another thing there. I'm going to not go offline I'm not going to close down the presentation so you can pick the details out of chat, because there's some really good leads in chat. And Sally, it'd be lovely to catch with you offline if that's possible. Thanks very much for attending. We are all of us are going to be at Interspill from the 21st to the 23rd of June. We have a Clean Seas Day, which will be on the 23rd of June. Please do come along and attend. It would be great to catch up with you. But thank you very much. This has been recorded. I'm just going to stop the recording, but thank you very much for joining. Eric, have you got a new hand up, or is that an old hand? Oh, it was an old hand. It was an old hand. Thank you.
Well, it's fairly old.
It's fairly old. Okay, no problems. But thank you very much. And wherever you are in the world, and it's lovely to see an international audience. Thank you very much indeed for joining. It's all been very hopefully useful, and it's good to get a mix of practical knowledge and campaigning on plastics. Thanks very much. Goodbye.
Thank you, Mark.
Thank you.
Take care, Mark.
Bye.